Hey, good, good. Do you folks hear me well?
Good.
See my screen? Okay, let's get going. And today I'm going to talk to you about some advanced tricks and practices for troubleshooting MySQL with Percona monitoring and management. This presentation is kind of more advanced than the intro presentations I've done in the last uh, conferences, right? So it's expects you to have some experience with PMM, but if you don't be worried, that will be okay too, right? Just that's why we're not talking about some very basic stuff. Let me go through some quick concepts, which I think is important to understand. Our approach is how we use PMM to troubleshoot variety of databases and MySQL in this case. If you look at any database technology from the application point of view, developer point of view, what database does is it serves the queries, right? And if you don't really care what's going on in the database kitchen, you just want to make sure what those queries are executed for you with a great performance, correct results. Often you also will be asked to make sure what your queries are not impacting other applications too much, right? And also maybe not using too much resources, right? Because especially in the modern clouds, often you can get a lot of performance even with a very bad, stupid queries, right? As long as you swipe your credit card enough times. So obviously, the queries are application responsibility, right? At large extent, because application is responsible for volume and a kind of queries it generates. Database can be then responsible or serving those better or worse. Now, another thing besides resources, besides queries to look at, is usually to look at resources. Because even if your queries are okay, if your resources are oversubscribed, you will have even very simple queries and good queries to run slow, right? And when we talk about resources, when it comes to their database technologies, right, we tend to focus on those for CPU, memory, disk, and network, right? And you'll hear about those through there through all my presentation. Okay. So if you do not know what PMM is, it is our purpose-built monitoring observability platform, right? There is a second M in PMM for management, but it doesn't do management yet. That's something we are working on, and name is kind of aspirational. PMM is 100% free in open source project. You can roll you on-prem or in the cloud. Like you can deploy it, for example, from Amazon Marketplace in a couple of clicks if that's your choice. And it supports the same technologies Percona's focus on MySQL and MariaDB, MongoDB, and Postgres. We also have support for cloud-based database deployments, such as Amazon RDS, in addition to your kind of do-it-yourself environments. Right. If you want to get more checks, more involved with PMM, here are a couple of links from you, right, to both download PMM. If you're not ready for that, you may want to check out PMM demo when you have a kind of full-blown PMM installation where you can look at various features, including some of the things that I will show you today. And we also had a number of webinars with PMM topics. You can also check that. Something not mentioned here is Percona's blog, which also has quite a bit of various blog posts about PMM. Okay, with that, let me try a switch seamless, hopefully between my screen and jump to the demo to see how I can show you some stuff. Okay. Well, the first feature in PMM, which we are very proud of, is the what you call query analytics, which allows us to really understand a lot about the queries which your environment runs. And you can see what by default we are sorting queries by the load, and this corresponds to pretty much the load those queries may generate, right? It kind of as a you can think about that as a combined query execution time, which was normalized, right? In addition to looking at your system by the query, you can also look at, for example, at the service name to see how load goes between your different database instances. You can look at that from a schema standpoint, which schemas are getting the most traffic, which is very valuable, especially for some sharded application. Right. You can also look at the usernames, right? And that is fantastic if you, especially if you follow best practice and have a different application using different usernames, you can see what are good users and bad users, right? Kind of in your environment. On the side, what you also see is by this metric, where does the load come from, right? Or you can choose something else, like if I would uh, if I would go and change to this column, right, to primary, then I can see it by, for example, query count. So in this case, we can see is while we have multiple costs and maybe they are serving the similar traffic, we can see what really for some reason majority of the load hits MySQL 4, right, and then MySQL 3 and MySQL 1 are kind of having it easier. With that, I can choose to filter by only MySQL 4, which will show me potentially different traffic, right? Then I can drill down on the single query, and guess what, right? This update query for some reason spends 99% of its time its time on a log time, right? I can also examine in this case more of additional queries. For example, how many rows it examines, how much it reads from a disk IO, rows effects, and so on and so forth, right? So this is just a high level overview what you can do with queries, right? And then from that, you often would go ahead and check example, explain for a query, right? We can see what this query is most likely to be a victim rather than a cause, right? Because, well, it just updated by the primary key, right? So it should not be really causing much trouble. So going on to talk a little bit about the resource usage, right? If you look at resource usage, we can also look at the primary sources, right? As we said, like the CPU usage. For CPU, we also like to look at the max CPU core utilization, right? Because in MySQL case, especially because many queries can be or because single query can be executed on one CPU core, only that means for some workloads you'll have a single CPU which is pegged. In this case, what is interesting is other is what our normalized CPU load, that is essentially how many queries are trying to use single CPU core, is 12, right? So that is very high, and that means that our CPU is super oversaturated in this case, right? Which is would be point of concern, right? Then you can look at the memory. IO activity. For IO specifically, I very much like to look at the disk IO latency, and especially how read and write latency compare to their historical the data. In many cases, when your disk IO will be over utilized, you will see what the latency really spikes compared to its historical average, right? In this case, we don't see a disk being a problem, right? This is disk in a cloud, so it's kind of latency of that is expectedly ebbs and flows, right? And I think what we also can see, I think, which is a very interesting for a lot of modern storage, what there is a huge difference between the average read latency and write latency, right? Which can go one way or another, but just like a point to measure and look at them separately, right? Then we also have the high level information about the MySQL, where we see information about its, threads, the different types of select their instance is running, right? Information about the network traffic, and some additional information. And if you want to drill down with MySQL, what the hell is going on? Most of us use MySQL with InnoDB storage engine, and for that we have the InnoDB dashboard, which really has a lot of very advanced information, right? If you look at that, there is really hundreds of dashboards which are grouped by different blocks, right? So, for example, if I am interested about what is going on with my disk IO in InnoDB, I can look at the InnoDB disk IO row to see how many IOPS which we have going on, what is the bandwidth that is taken, what is the IO going on to the disk IO, how many F-syncs are happening, right? F-syncs is kind of a very special kind of storage operation, right? Which often can create an additional and different load compared to your normal IO alone, right? And so on and so forth. Okay, now let me show you some more more advanced stuff. So one thing what is very powerful in PMM is what it is based on Grafana, and that allows you to create and customize various dashboards which may be specific to your environment and your needs. Like this is a dashboard I have created to really be able to see the queries which based on which is CPU heavy, disk heavy, network heavy, right, and so on and so forth, right? So for example, if I see what my CPU is overloaded and I want to find what queries are likely to hit CPU, I can use this functionality, right? And this will essentially tell me the CPU usage, information of the things which cause a lot of CPU usage in MySQL. That will be either large number of new connections coming in, or most likely large number of queries being run, right? In this case, it's 1,000 queries a second. And then what we are doing in this case, we have the queries which are sorted by something which I call a CPU core score, which is essentially, some formula which use the data about the query executed to compute how much CPU is likely to execute, right? So we can really see the queries sorted by that thing, right? So and again, as I mentioned, the real power in this case is what you can edit that dashboard if you like. In this case, that dashboard reads directly from ClickHouse, and that means you can actually edit how you want to play it, right? So what I decided in this case, we can say, well, the CPU score will be computed by number of queries we run, right? Because obviously there is some, CPU cost related to the query itself. Number of rows it examines, and the number of rows affected multiplied by the 100, right? Because we should assume what the modifying rows cost more CPU than changing the row, right? But again, you can decide to adjust that for any way you like in your environment, right? And this dashboard, as well as other additional dashboards, they are currently available from grafana.com. You can just import them in the PMM instance, right? So that's CPU intensive queries, right? Then you can also look and analyze the disk IO, right, which gives us both various disk IO information, right, which is relevant, as well as looking at the queries which have been IO intensive, right? And in this case, we're using different measures, right? We capture information about InnoDB read bytes, as well as how long it take to wait on IO, right? And create some sort of score, right? And in this case, we would see what this query is actually on this node also takes a lot of IO potentially. Okay, let me show you the next advanced dashboard which I created. Some of you may have heard about the red methods, which calls for oh my gosh, what to say? Well, it's the anyway. I just having completely brain fart what it stands for. But anyway, that is one of the methods to analyze their database performance, right? And yes, here is what is called for rate, errors, right, and duration, right, or latency. In this case, that is how we can exactly apply that. We can look at the query rate for this different instance. We can look at the error rate, which corresponds to this instance, right, which is kind of, pretty flat in this case, as well as we can look at the latency, where in this case, it was, designed what we are looking both at the average latency and 99th percentile latency, right? Because in many cases, applications will be affected by that much more than others, right? Then we can also look at the query rate and latency per node. In this case, we can see is, look at that actually for MySQL 1 and MySQL 4, MySQL 3 error rate is elevated. And we can also look to see their average latency in this case is substantially higher for MySQL 4, right, compared to the other nodes, which can help us then to jump to their particular graphs which correspond to a given instance, where you can get maybe more detail about that. So the cool thing about this, what I wanted also to show you, is the ad hoc filtering, which you can use. In this case, I have a very small environment, right? So it's not very interested. But if you have a complicated topology with number of environments, and you have a service which serve different purposes, and so on, so then you can drill down using this thing very conveniently, right? Like in this case, if I would say, well, I want to have only MySQL 1 as a node name, I can essentially filter on that, and you can see what all those summary dashboards have been refreshed to be only for MySQL, right? Again, in this case, that's kind of very trivial, but if you have a lot of instances in your environment, that can be absolutely fantastic. Well, finally, let me show you some of the extension things, how you can extend PMM to do more stuff, right? Like one of the things PMM currently doesn't instrument very well is MySQL memory instrumentation, which is available in MySQL performance schema. It provides, though, their solution, so you can add this or any other similar stuff to your instance, and that can be based on MySQL, standard tables, right, performance schema, or maybe your own tables which you have in the instance, right? For example, we had some customers which would use this to look at the number of orders which were, placed in the last last minute, right, or something like that, and correlate that with some technical MySQL metrics in the same PMM instance. So what we can do, or how we can reach that, is to use their custom queries. Basically, we can take any MySQL query, like in this case, you can see I am selecting the data from performance schema, and map that to the Prometheus data certain way, right? Like in this case, we're saying, hey, what event name that is going to be used as a label. There we will have a current bytes, and high bytes will be seen as their two metrics which we generate from that select, right? So and then what you do, you simply place this YAML file in a custom collector to MySQL. We have three directories here: medium resolution, high resolution, and low resolution, right? Which will will correspond to how frequently you want this collection to run. And you restart your agent, and you will have this data automatically captured. Now let's look at the dashboard, which I just created yesterday. One thing about creating your own dashboards, there is a lot of stuff out there if you're using PMM, right? Like there are links, like we have here, right? We have some other stuff like custom variables. You can see what we're fetching, and so on and so forth, which often is not very convenient to recreate manually. So what I do instead, if I want to create my own dashboard, I take the dashboard which is similar enough to what I'm going to create. Like if I'm creating MySQL dashboard, I will go to existing MySQL dashboard, do a save as, and then essentially remove all the panels from the dashboard, so I only have a bones left. Or maybe, as I did in this case, I left a couple of those high level summaries which were good. And then I went ahead and added the panel using this button bottom here, right? Interesting. Okay. Yeah, okay. So let's look at this memory summary and understand how the panels in Grafana work. So if you think, look in this case, the first thing is a Prometheus query, right? Even if you don't, Prometheus have relatively simple language, and even if you don't know that very well, you can probably find how to copy paste the formula. What we have in this case is MySQL performance schema memory summary current bytes. That is the name of a matrix, which you filter by service name equals service name, right? That's kind of corresponds to our MySQL 1 or MySQL 2, right? MySQL 2 doesn't have this extension installed, right? So it has no data. Then I'm saying what kind of legend I will go into plot here. In this case, that is an event name, template, and variable, right? And that's it. Then we can go and configure some settings which exist for panel. You will often use the title, You can also, what I like doing is specifying units, right? To specify what the unit is in bytes. And that really makes Grafana to automatically convert it to a megabytes, kilobytes, right? Wherever is appropriate. I specify linear, all right? And other things, what I do here, if you look at visualization, we're using lines, and I'm also using area fill, because what we want in this case is to see is, well, how much each of those things memory allocation take related to each other, right? I think which is good if they're fill appropriately and we're using stacking, right? Because if I don't use stack, then it's all will be kind of, collapse it on each other. And for things like memory utilization, that is not very is not very mm, is not very helpful, right? Okay. So that is what you would do. One thing I see I didn't do it here. What I like doing is making sure what we have 0, right? Especially with stacking columns, because if you don't, then it doesn't make much sense, right? So and let's just, for fun of it, also add something else here, right? So we have a top 10 which shows us top 10 services, but you'll say, well, you know what, top 10 is great, but I don't know how does that corresponds to all the memory usage which is instrumented by MySQL, right? If you want to add that, we can add another metric, right? We can do the sum of all the metrics available out here, right? And we'll see some value, which is, named here. We'll name it total, right? But you would see displaying total and non-total together kind of sucks, right? So to fix that, we'll use the series override, where we will say what for total. We want to use the line, right? We want to avoid the line field for that. We are going to remove stacking, and to make it more visible, we can change the color to be red, right? Now we can see both total amount of memory which all the MySQL instruments consume, as well as we can see top 10 memory consumers in MySQL, right? Hope that gives you the good idea how to work with these tools. Oh, and finally, something else which is kind of very cool, which I use a lot, right? If you have dashboard in PMM which does almost what you want but not quite, you can use this explore mode, which pretty much opens that in kind of a little bit kind of more geeky and maybe more technical interface. But you can, pretty much work with this in real time, modify that, maybe add some more filters, right, or something else, right, to analyze the data better based on the dashboard which exists in PMM. Okay, well, I am running out of time, it seems, but I am actually made it to the end of my planned presentation. So I hope you find that useful, and I would very much encourage you to install PMM if you haven't tried so. Check it out, provide them some feedback, or maybe, just maybe, even submit a pull request. And that is an open source project, and your contributions are highly welcome. Thank you. Kim, it's all yours.